So, had an idea this morning. If the Ivy League education system really wants to declare themselves to be the best way for them to prove that would be for a bunch of data scientists working on AI models to train different LLM models specifically based on the teaching styles and education systems of each of the Ivy League, I'm just going to call them franchises, like the difference between Stanford and MIT, or the difference between Harvard and Stanford, for example. Train an LLM like you would train somebody from those schools. Give them the basic education of those schools, and then give them, like, the same major or something so that you can compare apples to apples. And then run the standardized tests against them. Find out how well they each quantify things based on their input data, and have each school intensely curate that data so that there is no way for anybody to say, hey, look, this isn't representative of us, because that data set would then come from each of those schools. At that point, though, the big issue would be that each school would be effectively open sourcing their education system. And let's face it, Harvard bleeds red too much to do that, and Stanford doesn't care. So I don't think that's actually ever going to happen, but it's something that you can think about. And it's also something that I think, as I work with my own LLM solutions, I think about my next project with them, I'm going to be training my own model. And so I'm thinking about the input data because I want to have something that's useful and something that keeps its value over time. And so I'm looking at different input systems to try to figure out how that can be done in a way that will allow me to also leverage other data sets without creating bias. And that is the issue. One of the things you have to deal with when it comes to the LLM stuff is your input data is crucial. If you've got something that just is flat out wrong, or it's just bad data, it will totally mess up your model. And that's something that I think is kind of an analog to the human education system, because if somebody's given the wrong education, or they're taught the wrong things, then that builds a foundational model in their head for the rest of their life, and they actively assume the wrong things about the world because of it. And so one of the things that you have to understand is that as we get into AI more and more, we're also exploring our own humanity, because these processes are kind of analogs to how we think, and the people working on them are actively using their knowledge of humans to try to figure out how to hack the computer and make it more human. And so one of the things you have to understand is that somebody like me, who, well, I matriculated through various degrees in my 20s and in my teens, because I was a part of the high capability student program for my state, which is a fancy way of saying that I failed an IQ test by scoring too high, needing to be retested because I scored too high, and then scoring even higher on the next test, which completely destroyed my childhood. So, given what I know, I think it's going to be very interesting to see the race for LLMs, because the cat's out of the bag. I think there will be better models, but I think the curation of data is the best, because one of the things that I'm noticing is that when you deal with the training set of data, what you're really doing is you're just lowering the resolution. You're saying, look, in all cases, here's the science, and here's what you should be using for your thought process. And I'm summarizing, obviously, but what it comes down to is the data input's really important. And so one of the things that I am going to do, I would love to see the difference between not only the different educational systems, but let's look at some of the different religious systems too. Like, make an LLM that just practices a specific religion, and then have them face off with each other, and then find out and model, how aggressive they each are based on the religion only. And then figure out, using the data and being scientific about it, levels of risk associated with the different parts of the different religions. I don't think that'll happen. I don't think anybody would be brave enough to actually do that. because the pushback on that would be terrible for them. Because every single religion that they include in that will have somebody saying, hey, no, that's not us, even when it is in fact them. And so that's just going to be an issue. The fun thing about this, though, is if you actually scale that down and you say, okay, fine, let's stay away from these political topics. There's still a lot of interesting stuff that you can do if you train the model well using really good input data. And so the issue there is that everybody wants you to have like these gigabytes and terabytes of training data. And that's the wrong way of looking at it. The more accurate your model is, the less data you need. Because if you're going to just give them the mathematical function for acceleration versus training on lots of videos that describe acceleration, the model's going to have a much better idea of the math because they're just going to be using the core math versus trying to extrapolate that from watching videos of people throw balls. It's going to be a lot easier if you just input the page or two of mathematical data that explains how reality works, Newton's laws, that sort of thing, and then define the medium by which the ball is flowing and define, quickly what the ball is made of. And, if it's a ball of steel flowing through the air, that's pretty easy to model mathematically. And so one of the things you have to understand is that as the model gets smarter, its input data will be better curated. And eventually what's going to happen is everybody's going to get the same answer. And at that point, we know that that's standardized. We know that's done. And whenever that happens, and whenever that happens in a way that is verifiable through non-trusted third parties, that's when we'll get to the truth of the matter. And so if you keep doing the science, you'll realize that we're going to get these summation points. And eventually the resolution is going to get really wide from all these data sets that we're ingesting. And we're going to find some fun things. Because what's going to happen is we're also going to find a few answers that we weren't looking for. And that is what people are really excited about for the AI stuff, the LLM stuff. They're looking for the accidental answers, the convergence points of the statistical data that is being fed into these systems to find the mystery constant or number that scientists want to find. And it could be, you could just redefine pi, which is an ongoing race, which is because if you have the constant for pi, you can do math very quickly, and that allows you to do some very fun things. But when you really get down to it, what it comes down to is, I say that too much. But either way, when I say that too much too, I guess. But anyway, the fact of the matter is that in the end, which I'll say again, the better the model, the smaller the model. And so one of the things that you need to understand is that the large 30 billion parameter models right now, they're all running on 64 gigs of video RAM in a GPU, which most people don't have. And so if you have the high-end card, you've got like 32, not 64. So a lot of people are competing at the 32 level. And so what's happening right now is just kind of a race going on for the 7 billion parameter model, because that's even easier to load and more people can actually load it. It actually has enough reach and distribution. People can actually consume them, even if they only do a few tokens a second. And so the end result of all that is that when you are actually doing that training, what you actually want to do in the end is you want the smallest model possible. And so having a 7 billion parameter model versus a 30 billion parameter model is a big deal, because you have to validate that those 7 billion parameters are at least as good as the quality of the 30 billion parameters. But the fun thing about that is that because everybody's doing their own parameter set, their own data set, some of that data can just be copied and pasted, like literally just injected as an extra step in your build for the LLM. And suddenly you've got all this extra data, which can be a bad thing. But honestly, I think the best way to look at it would be to say, do the comparisons, train each model, do the comparison through a standardization, and then just flat out hold those educational institutions accountable. Call them out. Train each LLM model based on the different Ivy League faction that they are, and then when one of them loses, call them out publicly. Hey, you're not as good as this. You're charging this much more for this worse of an education. That is how the education system will be improved dramatically by getting the education system itself to compete with itself. But the only way to do that is to have somebody that has the academic credentials to make the education system actually want to listen. The only way you're going to be able to do that is if you take an LLM and you focus on a particular educational faction. And at that point, that faction is forced to defend itself, which means you can now do things like, oh, well, turns out your math classes aren't very good, but this model's math class is great. So why don't we took this school's math classes, which are the best, and added it to the social studies courses from the other school that was the best? See, now you know where I'm going. Because one of the issues with these schools is they also have political affiliations. And so because of that, you have political affiliations, which in turn control people's ideologies and shut off their ability to learn things because they have a bias. And so what you do is you take these LLMs, model them based on the Ivy League schools that they represent, and then when they're all fighting with each other over, their scores and the data and just looking at the academic side of things, you sneak in and you go, okay, well, this school has the best class in math. This school has the best class in social studies. This school has the best writing class. Let's just take the best parts of all these academic institutions, copy and paste them into the same model, train it. Oh, by the way, it's open source and it's free and available to everybody in the world. I would love to be a part of something like that, but I just don't have the hardware. But if you do, let me know.